dyes and pigments which surround us with color, pharmaceuticals to improve our health, products which reaffirm the value of science to mankind. As part of its continuing program in support of science education, Ciba-Geigy is pleased to present this issue of the Science Screen Report. The Science Screen Report, bringing you each month the latest developments in science, engineering, and medicine, made to help solve the problems of modern life. Just beyond the world's shorelines lie the continental shelves, submerged lands rich in fossil fuels, food supplies, and other critical resources. Currently, along the coastline of Alaska, a long-term environmental assessment program is underway, aimed at anticipating and dealing with environmental problems arising from the development of the offshore areas. Today, at the top of North America, the offshore regions of Alaska are about to undergo intensive development. To prepare to cope with possible future pollution here, the National Oceanic and Atmospheric Administration is carrying out an environmental assessment program. The resulting discoveries, ideas, and technology should be useful in safeguarding coastline ecosystems around the world. Both volcanoes and earthquakes are important facets of the Alaskan coastal environment. These geological features must be assessed to learn how they will affect oil drilling operations. The assessment program includes evaluations of each feature and fault. How likely are quakes or eruptions here? How powerful could they be? How might they reach out to alter conditions in the drilling zones, far out of sight of land? Studies of the coastal seafloor led to the charting of seismic zones, regions which, subject to quakes, might not support oil drilling platforms. As a result, drilling platforms will not be built in these locations. To gain knowledge about ice movements, which might also wreck drilling platforms, radio buoys are embedded in the ice pack, then continuously tracked via satellite. The tracking program charts major ice flow patterns, which can then be avoided by future drillers. Radio beacons are used to map changes in ice pack shape and motion. Advanced side-scanning radar determines ice age and thickness. Some of this ice was formed more than 10,000 years ago. The seawater is also being probed. Instrument arrays are used to record current rates and patterns, as well as other ocean behavior. Collection bottles sample the ocean's composition. Grabs, like this one, gather data about the sea bottom and its inhabitants. New technology employed for the first time includes a radar system designed to sense both surface waves less than a meter high and currents up to 50 kilometers offshore. This radar can track currents which might transmit pollutants and therefore predict the spread of a possible spill. At the University of Alaska, seawater samples are analyzed to find pre-drilling pollution sources, such as seabed oil seepages and river runoff. These baseline levels will be the basis for measuring possible future pollution. These are natural Alaskan bird rookeries. Currently, several groups of assessment program scientists are recording patterns of bird behavior, hoping to use behavioral changes as sensitive indicators of possible alterations to the environment. A related investigation is being conducted by ornithologists and other experts from the University of California. Here, a researcher traps and takes measurements of one migratory bird specimen. Many such birds depend upon coastal tidal areas for food and nesting grounds during their annual journeys. Other biologists study the elusive mammals of the northern seas, the whales. Of the many different species, the gray whales annually migrate over 10,000 kilometers to warm Mexican waters to mate and give birth. Nearby, beaches teem with sea lions. Experts periodically visit specially tagged members of this enormous community, part of a study of their susceptibility to environmental changes. The wet margins between sea and land are also probed by the scientists, studying bottom life, sampling plants and animals, establishing pollution control guidelines for each unique species. Such wetlands are rich habitats for fish and wildlife, natural filters of pollutants from water, and buffers against storms and floods. Note the variety of specimens from even a small area. Other experts map the landward side of the biome, the sandy, rocky edge of the deep sea food web. The census takers work their way down the shoreline, grid by grid, plant by plant. Interviews with longtime coastal residents, fishermen, farmers, boatmen provide more information about the history of the changing life patterns along the critical shore. Out at sea, complete societies of deep-sea life are hauled up for analysis by the research teams. All aspects of the assessment program have one goal: the accurate mapping of every part and system of the environment. Later, the collected data will be used in two basic ways. First, whenever possible, to anticipate and forestall environmental damage. Second, if such damage does occur, to provide a baseline for measuring its nature and extent, the first step in restoring the delicate life web. At a laboratory in Seattle, Washington, fish in a controlled experiment are exposed to precise amounts of crude petroleum. Carefully, the consequences for the fish and perhaps fishing grounds are measured and recorded. Increasingly, computers are valuable tools in this work. This one is able to predict the pattern of spreading foreign matter in the sea. Computer studies of space images revealed kilometers-wide whirlpools in the ocean. Since these immense currents touch both proposed drilling sites and coasts, they could deliver pollution into the food web. Now the assessment program data becomes the basis for deciding whether or not to drill at a particular location. The Outer Continental Shelf Environmental Assessment Program, safeguarding Alaska's shoreline and providing new knowledge to protect the world's coastal ecosystems. Science Screen Report has been presented by Ciba Geigy Corporation, with headquarters in Ardsley, New York, as part of its continuing program in support of science education.